Is blindness a barrier? No.
Is deafness a barrier? No.
Are mobility, learning, cognitive disabilities, speech impairments and others, or even a combination of them, barriers? No way. Lack of accessibility is.
Welcome to Web Accessibility for All.
Follow the blind. This journey starts now.
A brand new web game drops. Stunning graphics inside a massive 3D world. Everyone is talking about it. So you load it up, but the second you touch your keyboard, nothing. Nothing at all.
Game over!
For almost 2 decades, it has evolved in power, but not in accessibility. Today, we are going to dive deep into the HTML canvas element from the perspective of accessibility, for sure. Ariel here, and welcome back to Web Accessibility for All.
HTML Canvas Accessibility, 20 years of challenges and limited progress.
Think back to 2004. Apple drops a brand new toy called the HTML Canvas, and suddenly the web feels alive. We finally had a way to draw, animate, and create without Adobe Flash. It was fast, it was shiny, but it was also fundamentally hollow. Canvas is what we call an immediate mode rendering system. You draw something and the browser forgets it as an object. When HTML5 was standardized, it gave us real semantics. The browser could finally understand what things are, not just how they look.
But the canvas?
It stayed in the dark ages.
A systemic failure in accessible web graphics.
In retrospective, we've spent 20 years building games that a blind child can play. Professional tools a developer with motor disabilities can't navigate. We traded accessibility for frames per second.
Why HTML Canvas is a black box for screen readers and assistive technology?
Here's the real problem. The browser builds an accessibility tree from the DOM. Screen readers don't read pixels, they read that tree.
And the canvas?
It's a total black box. Inside the canvas, there is no tree, so there is nothing to expose.
The fundamental disconnect between pixels and the accessibility tree.
In a standard web page, the structure and the presentation are connected. A button isn't just something that looks clickable. It is a button with a role, a name, and a state. In a canvas, they are completely severed. Essentially, the canvas is a memory space for raw data. It has no inherent memory of the objects you draw. Since the browser engine isn't tracking the object inside the canvas, it can't pass that information to the accessibility tree.
The rise and fall of the Canvas Hit Regions API.
So, did anyone actually try to fix this? Surprisingly, yes. Enter the Hit Regions API. The idea was actually quite clever in its simplicity. It would allow a developer to draw a shape on the canvas and then tell the browser,
hey, if the user clicks inside these coordinates, they are actually interacting with button A in my hidden code.
It was meant to link the visual pixels to the semantic reality. Sounds like a game changer, right? But then the wheels fell off. The actual implementation was a disaster. Browser vendors couldn't agree on how to make it work consistently across the board. The fallout from this failure was massive. The API never gained consistent cross-browser support, and it quietly faded away.
Canvas fallback content and its limitations.
If you ever looked at a tutorial on Canvas accessibility, this is a low-hanging fruit they always point to. You place real HTML inside the Canvas element, and Assistive tech can access it, even though it's invisible on the screen.
Less canvas. ID equals game greater. Less button. ID equals jump greater. Jump. Less slash button greater. Less button. ID equals shoot greater. Shoot. Less slash button greater. Less slash canvas greater.
Since browsers don't render that content visually, it becomes a shadow for Assistive tech to find. It sounds like a win-win, isn't it? You've got your shiny pixels on top, and your screen reader support tucked neatly underneath. But here is the catch. Imagine a stock trading dashboard, updating in real time. Visually, prices are changing every second, but your fallback content still says
Apples, $120.
that's not just outdated, it's misleading.
What do you mean, Ariel?
When we rely solely on the fallback content, we are essentially telling disabled users that they only deserve the summary of the experience, not the experience itself.
WebGL accessibility challenges and the cost of making 3D content accessible.
When we move from 2D and enter the world of WebGL, that opaque surface doesn't just get darker, it turned into a total void. In WebGL, we aren't even dealing with pixels in a grid anymore. We're dealing with shaders, vertices, and coordinate buffers. So how do we make a WebGL 3D environment accessible? This is where we have to use what is called the mirror DOM. The mirror DOM is about building a parallel, invisible HTML universe behind the scenes.
Less div. Ariel equals polite. ID equals announcer greater. Less slash div greater. Blank. Less all. ID equals objects greater. Less ly greater. Door. Less slash ly greater. Less ly greater. Key. Less slash ly greater. Less slash l greater.
If a player moves near a door in a 3D scene, your mirror DOM might update.
Door ahead.
You are essentially running two versions of your app at the same time.
Oof, a massive amount of work.
Well, it is.
But why do we do it?
Because in a complex 3D space, a user needs to know where they are in space. Game engines like Unity or Play Canvas are starting to handle this by generating accessibility trees on the fly, but it's still a simulation of access, not native access.
Keyboard accessibility in Canvas, designing keyboard-first interaction models.
Most of us navigating the web with NVDA or switch access aren't hunting for pixels. We are flying through sequences. What if we make the keyboard the primary logic controller?
Mapping user input to logic for better accessibility.
Your Enter, Space, Arrow, and Backspace keys directly change the state of the canvas. If I press the right arrow, I'm not just moving a focus ring, and moving the actual logical position. Keyboard logic alone is not enough. You also need a way to announce changes. That usually means ARIA-lib regions.
Announcer.text content equals you move to the next item.
Or updating the accessible name of the focused element. But there's a catch.
The lack of native focus control in Canvas.
The canvas has no native focus state. To fix this, we need to build a virtual focus ourselves. We have to programmatically draw a visual highlight on the canvas that follows the keyboard input in real time. You are essentially managing two focus systems, a visual focus drawn on the canvas and a semantic focus in the DOM. JavaScript handles the logic and the announcements, while the canvas draws the feedback for anyone who can see it.
But why go through all this trouble?
Because rapid-fire key commands are infinitely more efficient than a cluttered DOM tree. Think about a complex game or data tool. Would you rather tap through 50 invisible buttons or just use a quick sequence of arrows to get where you need to go? By focusing on keyboard sequencing, we're creating a high-performance interface that actually respects the user's skill.
Why SVG is often the accessible alternative for web graphics.
Up to this point, you're probably wondering,
We don't have to spend half our development time building hacks just to let someone use a keyboard.
Is there a better way?
the answer is a resounding
Yes!
and it's been sitting right in front of us the whole time.
Scalable vector graphics.
If Canvas is a black box, SVG is a glass box. Everything inside the SVG, every circle, every path, is a living, breathing part of the DOM.
Improving accessibility, semantics, and keyboard navigation.
SVG gives you the opportunity to build accessible graphics using standard web tools. When you create a circle in SVG, the browser knows it's a circle. You can give it an area label, a role, and most importantly, SVG can natively receive focus. For most interface-driven graphics, charts, maps, and diagrams, SVG is usually the better choice.
Canvas accessibility on mobile devices and testing strategies.
Canvas accessibility in mobile.
On mobile, things get trickier. Screen readers like TalkBack or VoiceOver rely on gestures, not coordinates. A canvas that depends on precise taps or drag gestures becomes almost impossible to use.
Testing accessibility, screen readers and keyboard.
Start simple. Turn on your screen reader. Can you read anything? Can you understand what's happening? Inspect the accessibility tree. If it's empty, that's your first red flag.
Rethinking Canvas accessibility and building inclusive web experiences.
So where does this leave us? It's easy to get discouraged and think that accessibility in a Canvas world is just too much work. But that's exactly the mindset we need to break. We have to stop treating accessibility as a feature we add at the end of a project if we have time left over. Thanks for listening to Web Accessibility for All. Keep building, keep testing. If it isn't accessible for everyone, it isn't finished yet. I'll see you in the next episode. Goodbye.
Thanks for joining us today. Subscribe for a new challenge next week. And don't be shy. Leave us a review or ask your accessibility questions online. See you next week for another episode of Web Accessibility for All.